In our short lesson today, we're going to take a look at how to graph y equals sine x, y equals cosine x, and y equals tangent x. And then when we're done, if you want, you can graph these on Desmos and just compare. All right, so what we're going to create is just sort of one cycle, and I'll explain what this means once we do this. So what we're going to do is we're going to make a table of values first. So I'm going to call it x, and then since y is equal to sine x, we'll just say sine x. We always start graphing by making tables until we fully understand the idea here. So I'm just going to pick the axes values. So we're going to do 0, pi over 2, pi, 3 pi over 2, and then 2 pi at the end. Now I'm going to go to the unit circle and figure out these values. So we're looking at all the ordered pairs, all the second numbers of these ordered pairs. So at 0, the ordered pair is 1, 0, so sine of 0 is going to be 0. Next, if we go up to 90 degrees, pi over 2, the second number there is a positive 1. Go over to pi 180 degrees, the second number there is 0. Go down to 3 pi over 2, 270 degrees, that's going to be negative 1. And then 2 pi is back at 0, so we have a 0 here. So our x values, and try to space them as evenly as possible. We'll have pi over 2 first, with zeros right here at the origin. Then we'll have pi. Then we'll have 3 pi over 2. Then we'll have 2 pi. Now the y-axis includes the value 0, 1, negative 1. So I'm going to go up here to 1, and then down here we'll say negative 1. So I'm going to make these 5 special points. We have a point here at 0, 0. Pi over 2, we go up to 1. Pi, we're back at 0. 3 pi over 2, we're down here at negative 1. And then 2 pi is 0. Now we don't draw line segments. These are not going to look like straight lines. This is going to be a curve. So we want to arc this or arch this as best as we can here, up to here. And then we'll come down. Same thing here. This is a curve, so we'll curve down this way and then back up. Now the rest of the graph just repeats this cycle. So we say pretty much from here, from 0 to 2 pi, we call this one cycle or one period of sine x. So all of these are called periodic functions because they keep repeating. So we're actually going to continue this now off to the left without making a table. I'm just going to do the opposite here. So like right about here will be negative pi over 2. Then we'll have negative pi, negative 3 pi over 2, and then negative 2 pi. Now negative pi over 2, that's going down to 270, but in a clockwise rotation, so that would be at negative 1. Negative pi is the same as pi here, so we're back at 0. Negative 3 pi over 2 would take us a clockwise rotation up to pi over 2, so that would be at positive 1, and then we're back down at 0 at 2 pi. So then another full cycle or period would look like this. And the graph continues. So let's go to Desmos. I just want to show you. If we were to type this in, now if you're going to use Desmos, you have to use this functions button right here, and we want to go up here to sine, and then just x, so I'm going to make that lowercase. And here we could see this goes on forever. The domain is going to be all real numbers, but these are the parts that we graph. So here we have 0, 0. Here's pi over 2, 1. Here's pi 0. Here's 3 pi over 2, negative 1. Here's 2 pi and 0. Right here is negative pi over 2, negative 1. Negative pi 0. Negative 3 pi over 2, positive 1. And then negative 2 pi 0. So that's what we graphed by hand. All right, let's take a look at cosine x. Again, we're going to make a table with x and then cosine x. I'm going to use the same 5 x values I used for sine x. So that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. But now we're going to the first numbers of all the ordered pairs. So at 0, cosine of 0 is 1. Pi over 2 up there at 90 degrees, the first number is 0. Over at pi, 180 degrees, the first number is negative 1. 3 pi over 2, that first number is 0, and then we're back to a positive 1. So I'm still going to make pi over 2, pi, 3 pi over 2, and 2 pi. And then just on the opposite side, 2 will go negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Again, we're going to go up to positive 1 and down to negative 1. All right, but here, when x is 0, cosine is 1. So sine starts at the origin, or goes through the origin, where we normally start it, and cosine on the y-axis is at 1. Pi over 2, now we're down at 0. Pi, we're down at negative 1. 3 pi over 2, we're at 0. And then 2 pi, we're back up at 1. And we're going to draw the same curve. Again, we don't draw line segments. This is not supposed to look like a V shape. It is still going to be a curve. So from 1, or from 0, x equals 0 to x equals pi over 2, we start to kind of arch down this way. We call this concave down when it's shaped like this. And then we curve the other direction. We call this concave up when it starts to look like we're drawing part of a smile. We want to continue that smile going up to this point. And concave down we consider to be like a frown, so we want to draw part of a frown right here. So from x equals 0 to x equals 2 pi, this is 1 period of y equals cosine x. We're going to continue on the other side as well. Now negative pi over 2, we're down at really 3 pi over 2, so that first value is going to be 0. Negative pi is the same as being over at pi, so that's going to be negative 1. Negative 3 pi over 2, we're up at pi over 2, so that's 0. And then negative 2 pi, we're up there at positive 1 again. So again, we're going to be finishing our frown over here, turn into a smile, over to 3 pi over 2, close enough, and we continue this way. So I'm going to go back to Desmos and show the graph of this. I guess it does work for capital letter as well. All right, so here we are at 0, 1. There's pi over 2, 0. Pi negative 1. 3 pi over 2, 0. 2 pi 1. There we're at negative pi over 2, 0. Negative pi negative 1. Negative 3 pi over 2, 0. And negative 2 pi 1. So they're very similar in their appearance. It's just the points they go through are going to be different. All right, so let's try one more. Let's go ahead and graph y equals tangent x. Now this one's going to be a little different. I'm going to create more values to take a look at here, so we need some space. So we're going to have x and then tangent x. So I'm going to start with 0, but I want to bring in the pi over 4 families here. So I have pi over 4, then I'll go to pi over 2. So I'm halfway in each quadrant. So I want to still continue this. So now we're going to be at 3 pi over 4. We're in the middle of the second quadrant, and then we go to pi. Middle of the third quadrant will become 5 pi over 4. And then we'll go to 3 pi over 2. So that should be enough here. So we have 0. Here's our pi over 4. Here's our pi over 2. 3 pi over 4. Pi. 5 pi over 4. And then 3 pi over 2. All right, so here we have to divide sine by cosine. So at 0, our second number is 0, first number is 1. So we're taking 0 divided by 1, and that's 0. Pi over 4, notice they're both radical 2 over 2, so if I divide one number by itself, that's just a 1. Pi over 2, we're at the ordered pair 0, 1. So if I take sine divided by cosine, that's actually 1 divided by 0, and that's undefined. 3 pi over 4, we're at negative radical 2 over 2, and then positive radical 2 over 2. So if I divide opposites, that's a negative 1. At pi, our ordered pair is 0. I'm sorry, negative 1, 0. So we're dividing 0 by negative 1, so that's 0. 5 pi over 4, I'm in the middle of the third quadrant. Both radical 2 over 2s are negative, so I'm back at a positive 1. And then 3 pi over 2 is at the bottom at 270, so that ordered pair is 0, negative 1. So if I divide negative 1 by 0, that's also undefined. So notice where our graph will be undefined. Here we're going to draw in vertical asymptotes. So if you have some sort of a straight edge or ruler to trace here, please make sure you do that. So we're at pi over 2, we're going to draw a vertical asymptote. And then also at 3 pi over 2. So I'm going to focus between these two right now. So at 3 pi over 4, let me put a 1, and we'll do a negative 1. So at 3 pi over 4, we're down here at negative 1. At pi, we're at 0. And then at 5 pi over 4, we're at positive 1. Now, this isn't an arc like sine and cosine. It's not a curve like that. What happens is, as we keep moving closer and closer to pi over 2 from the right, our graph is going to keep going down. So what I'm actually going to do is start to come up right here, turn a little bit, go through this point, continue up here going through the x-axis, and then turn here to gradually go up like this. And it's a series of these types of curves that are right here. So over here at pi over 4, we'll be up at 1, and then we'll have 0. I'll continue this over here. If we had a negative pi over 4, and then we have a negative pi over 2. Negative pi over 2 would give us another vertical asymptote. So if this is at 1 here, 0, then negative pi over 4 would be right here, and then the curve would kind of continue. All right, so from here to here, this would be one period of y equals tangent x. And again, this looks the most complex out of all three of them, but this would be a series of these curves. So let's take a look at what that looks like on Desmos. So they don't draw on the vertical asymptotes, but we could see, I'm actually going to write this in. So let's just do I actually want that to be x. So here's my one vertical asymptote here, and I'll do that as well. We'll do three pi over 2. So here are my two vertical asymptotes that I have in there. So here we have the point pi 0. It's a little bit tougher. I'd have to type these in, but we would be at 3 pi over 4 and then negative 1 here, and then this would be 5 pi over 4 and a positive 1 right there. Then you can see right here, there's our 0, 0. But again, it's just a series of these types of curves. It's not always the easiest to draw. All right, so now you guys have seen and generated the graphs of y equals sine x, cosine x, and tangent x. Now, if you wanted to just explore, you could type in on Desmos y equals cosecant x, y equals secant x, and y equals cotangent x, just to get an idea of what those look like. All right, so I will show you the filled out form tomorrow, but continue yesterday's assignment filling in all of those ratios or exact values pertaining to the unit circle.